Our next set of identities are our power reducing formulas. The first one is sine squared u, which is equal to 1 minus cosine of 2u over 2. And then we have cosine squared of u, which is equal to 1 plus cosine of 2u over 2. And finally tan squared u, which is equal to 1 minus cosine of 2u all over 1 plus cosine of 2u. Now we'll look at a couple of examples demonstrating the use of our power reducing formulas. So here I'll be using the power reducing formula to rewrite the expression sine to the 4th power of 2x in terms of the first power of cosine. First, we can rewrite this as sine squared 2x all squared, because this squared will give us to the 4th power. In this form, we can use our power reducing formula. We know the sine squared of 2u would be 1 minus cosine 2u over 2. Since here our 2u is x, this becomes 1 minus a cosine of 2 times u, or 2 times 2x, which gives us 4x all over 2. And this is being squared. Now if we expand this by squaring the numerator and the denominator, we get 4 on our denominator. On our numerator, we get 1 minus 2 cosine 4x plus cosine squared 4x. If we factor out the 1/4 from all three terms, we're left with 1 minus 2 cosine 4x plus cosine squared 4x. Now here, this piece is already to the 1st power of cosine. But here, this is cosine squared. So we can use our power reducing formula for cosine squared and write it as a single power of cosine. We know for cosine squared u, it's 1 plus cosine 2u over 2. So since this is 4x, this becomes 1 plus cosine 2 times 4x, which is 8x over 2. If we factor a 1/2 from each of these terms, becomes 1/2 times 1/4, which gives us 1/8, times 2 minus 4 cosine 4x plus 1 plus cosine of 8x. If we combine our like terms inside the parentheses, we get 1/8 times 3 minus 4 cosine 4x plus cosine 8x. Here we have single powers of cosine. Our next set of identities is our half angle formulas. First, we have the sine of u over 2, or the sine of 1/2 of u is equal to plus or minus the square root of 1 minus cosine u over 2. Or we have the cosine of u over 2, or the cosine of 1/2 u is equal to plus or minus the square root of 1 plus cosine u all over 2. For tan of 1/2 u or u over 2, we have two alternatives. The first is 1 minus cosine u over sine u, and the second is sine u over 1 plus cosine u. So here I'll be using this figure to find the exact value of sine of theta over 2 and secant of theta over 2. In the diagram we're given theta here. That means our opposite is 8 and our adjacent is 15. Using our Pythagorean theorem, we can find the hypotenuse, which is 15 squared plus 8 squared, and the square root of that gives us 17. We know that the sine of theta over 2 is equal to plus or minus the square root of 1 more minus cosine u over 2. Now that we have our hypotenuse, we can find the cosine of u. Cosine of u, or theta in this case, would be 15 over 17. So this becomes 1 minus 15 over 17 all over 2. 1 minus 15 over 17 is 2 over 17. If we divide this by 2, this becomes 1 over the square root of 17. Rationalizing the denominator, we get the square root of 17 over 17. To find the secant of theta over 2, we use a reciprocal identity. We know that secant is 1 over cosine. So we could rewrite this as 1 over cosine theta over 2. We know that the identity for theta over 2 is 1 plus cosine u all over 2. So now we have 1 all over the square root of 1 plus cosine of u, which is 15 over 17 all over 2. Simplifying this and finding the reciprocal, we get the square root of 17 over 4. In this example, we're going to use our half angle formula to determine the exact value of the sine, cosine, and tangent of the angle 165 degrees. Now 165 degree is not one of our special angles on our unit circle, but we can rewrite 165 as 330 degrees over 2. So now this gives us our half angle identity. So this becomes the sine of 330 over 2 be equal to plus or minus the square root of 1 minus cosine u, which in this case is 330 all over 2. We know that cosine of 330 is the square root of 3 over 2. So 1 minus square root of 3 over 2 over 2, find the square root of that. Once we simplify this, we get 1/2 times the square root of 2 minus the square root of 3. Similarly, to find the cosine of 165, we can write this as a cosine of 330 over 2. Using our half angle formula, this becomes 1 plus cosine of 330 over 2. Now it's negative here because we're finding a cosine of 165 degrees. And we know that 165 degrees is in our second quadrant and cosine is negative in our second quadrant. Here this was positive because sine is positive in our second quadrant. So now we have negative 1 plus cosine of 330. The cosine of 330 is the square root of 3 over 2. So this becomes 1 plus the square root of 3 over 2 all over 2, and then we're going to find the square root of that. Simplifying all of this, we have negative 1/2 times the square root of 2 plus the square root of 3 under the radical, and it should be a negative here. So here, cosine of 165, the exact value would be negative 1/2 times the square root of 2 plus radical 3. To find the tangent of 165, we can do the same thing, 330 over 2. The identity for this would be sine of 330 over 1 plus the cosine of 330. So this is sine of negative 1 of 330 is negative 1/2. So this becomes negative 1/2 over 1 plus the square root of 3 over 2. Our algebra here is a little tricky, but once you simplify this, it becomes the square root of 3 minus 2. Here we're going to determine the quadrant in which u over 2 lies and find the exact value of sine of u over 2, cosine of u over 2, and tan of u over 2 using the half angle formulas. We're told that the sine of u is equal to 5 over 13 and that u is between pi over 2 and pi. So pi over 2 and pi is in our second quadrant. Therefore, u over 2 must lies in the first quadrant. It's a half of the second quadrant. So our first answer for part A would be quadrant 1. We're given that sine of u is equal to 5 over 13. So we know from sine, this is our opposite over our hypotenuse. Using our Pythagorean theorem, we can get the adjacent side, which comes out to be 12. Now we can proceed to find our sine of u over 2. We know sine of u over 2 would be equal to the square root of 1 minus cosine u all over 2. And here our sine is positive since our angle is in our first quadrant. So this becomes 1 minus cosine of u, and the u is in our second quadrant, so this is negative, so it's 1 minus negative 12 over 13 all over 2. When we simplify this, we get 5 square root of 26 all over 26. To find the cosine of u over 2, this is equal to 1 plus cosine u all over 2, and then we're finding the square root of that. Once again, this is a positive answer because u over 2 is in the first quadrant. The cosine of u, as opposed to u over 2, is in the second quadrant, so u is negative, so this becomes 1 plus negative 12 over 13, or just 1 minus 12 over 13. Simplifying this, we end up with the square root of 26 over 26. Now we can use our half angle identity to evaluate the tan of u over u, or we can use our quotient identity. We know tan is equal to sine over cosine, so the tan of u over 2 is equal to the sine of u over 2 all over the cosine of u over 2. We have already established that the sine of u over 2 is 5 times the square root of 26 over 26, and the cosine of u is equal to the square root of 26 over 26. So if we cancel these two, we're just left with tan of u over 2 is equal to 5.